Let me see if some more people want to join. Okay. Okay. Okay, so I'm sharing a screen with you. That's going to be like uh, the board that I will be using. Can you all see it?
Yes, miss.
Okay. Okay, so maybe let's start by looking at the homework that I asked you to do yesterday. So that one, it was pretty simple. I think most of you were able to do it, I hope. Or were there any problems with that one? Okay, the first one was x to the power of y is equal to 191. Now you were told to rewrite this as a logarithmic equation. Remember what I said, that x over here, this is your base, and y is your exponent, and then this 91, this is here. Are we fine?
Yes, miss.
Okay. Right. Maybe you can just go ahead and mute all your mics, and then if you have a question, unmute it. Okay. So this 191, this is your argument. And when you want to rewrite an exponential equation as a logarithm, the subject of the formula is always your exponent. Somebody wants to join. Let me just admit them. Okay, so the subject of the formula is always the exponent. So I will say y is equal to log of the base. The base is x, and then the argument 191. So that is how I would write that one. Okay, so the others, I would do them in pretty much the same way. Number 2, y to the power of x, this is equal to 1. So I follow the same procedure. The exponent is equal to log to the base. Here my base is y, so log to the base y, this is equal to 1. Number 3, scroll down. Number 3, x to the power of minus 13 is equal to y. Okay, so again, log to the base of the argument, this is equal to minus 13. So you can also start minus 13 is equal to that. In either case, minus 13 is the subject of the formula. Number 4, 17 squared is equal to 289. Okay, so the exponent is the subject. 2 is equal to log of the base, which is 17, and the argument, this is 289. Then number 5, square root of 36 is equal to 6. Maybe in the on e-learning or square root of 16, I'm not sure, but the procedure that you'll do it is exactly the same. Square root of 36 is equal to 6. You need to just remember that square root of 36, you can write this as an exponent. So this is the same as 36 to the power of half is equal to 6. Square root means to the power of half. Then your answer is still exponent is equal to log to the base of 36 of 6. And that is how you would do this one. Let me see if I can enable a chat, then you guys can make comments. Okay, there's a chat over there. Should be on the right, or you can click on the chat icon there. So if you have any questions at any point, then you can still just type them in there. Okay, let's move on. The second question, question 2. First one, I have log 550. This is equal to k. Now I'm doing the opposite. I have to rewrite this as an exponential equation. So here you just need to remember again, this is, somebody wants to join. Let me admit them. Okay. That 5 is the base, and the subject of the formula is your exponent, and then that is your argument. So it is always base exponent is equal to argument. So that's how you would rewrite it. Number 2, I have log the base 9, 1 over 81. This is equal to minus 2. So again, it is base to the power of the exponent. This is equal to the argument. So very simple. The third one, log 169, 13. This is equal to a half. Then again, it is base exponent. This is equal to 13. And you see, power of half means a square root. So the square root of 13 is, sorry, the square root of 169 is 13. And number 4, I have log x is equal to y. Here, mention that if the base is not written, here you can see there's no base written, unlike the previous questions that we did. This means that the base is equal to 10, and this is what we call a common logarithm. So this is a common logarithm. Okay, so it's not a mistake. This is the same as log 10 of x is equal to y. And then to rewrite it as an exponential equation, it is just base 10 exponent y is equal to my argument. And then the last one, 5, ln of x is equal to y. Now ln of x, this is the natural logarithm. So it is the natural log. And natural because the base is the number e. You can press that on your calculator. It is, let me see, 2.7 something something. Okay, and this is the same as log base e of x is equal to y. So ln is just a shorter way of writing log base e. This part over here is the same as ln. And when we rewrite it as an exponential equation, we do it in exactly the same way. It is base exponent is equal to the argument. And that's it. So I'm sure you got all those right because they're not too difficult. Now, if we don't have any questions, we will move on to the next thing, which is the anti-logs. Okay. Now, anti-logs, you need to keep in mind this relationship that we have. Now, let's say I give you log of x is equal to y. Now, in the examples that I've been doing now, we've changed this exponential equation into a logarithmic equation, and we said that 10 to the power of y is equal to x. Now if this is true, this equation over here is true, then it means that that is true. Now with antilogs, where they come from is, if for example I give you something like this, I say 2 to the power of x is equal to 5, and then I say, can you solve for x? What you will do is you'll say, okay, I'm going to divide by 2 on both sides. Now someone will ask you, why are you dividing by 2 and not say multiplying, not multiplying or adding or something like that? And the reason you would give them is that here what is happening to x is you are multiplying. Now to get rid of this multiplication, you have to do the opposite of multiplication. And the opposite of multiplication is division. So antilog is like an opposite of log. Okay, so also another one is, if I had square root of x is equal to 5, I want to get rid of the square root. I'm not going to divide by square root. There's no such thing. What I will do is I will square both sides. I square. Okay, and because squaring and square root are opposites, then they will cancel each other out. Okay, so we go back to the question that we had over here, which is log x is equal to y. So I'll write it again here. Log x is equal to y. Now I want to get rid of the log because I want to make sorry John, I just see your message now. You didn't miss very much, and I'm recording this, so anything you missed you can watch it later. Okay, right, so here I want to get rid of the log. Now I cannot say divide by log like this. Divide by log, divide by log. This is not allowed because log is not a number. Okay, just like with the square root, I didn't divide by square root. I performed another operation, which is the opposite of square root. So to get rid of the log, I will take antilog on both sides. So I say antilog of log x. This is equal to antilog of y. Now on this side, I'm taking antilog and then log. That means I will have x left by itself, because when I square and then take the square root, I'm just left with whatever I was taking the square of. And then on this side, I cannot simplify it, so I leave it as antilog of y. Now if you remember at the top, I had this equation over here, this one, and x was the subject of the formula. I said if I have this logarithm, then it means the same thing as this one. Okay, so if I have this, the subject of the formula is x. Now I've made another equation over here, and the subject of the formula is also x. Then it means that those two equations are equal. I can equate them. So I'll write the other one. This was x is equal to 10 to the power of y. So these two equations are equal. So you know when you're solving simultaneous equations, one method that we use is you make x the subject of the formula in both of them, and then you combine the two equations. That's what I'm doing over here. Okay, so here I can now write that antilog of y is equal to 10 to the power of y. So here I think you can see that if I have antilog of something, this y, all I need to do is just take 10 to that power. So if I ask you, what is antilog of 5? Okay, so you'll say, oh, okay, look at what happened to y. When I took antilog of y, it became 10 to the power of y. So when I take antilog of 5, this must just be 10 to the power of 5. Okay, so antilog of half, this is just 10 to the power of half. So antilog of anything just means that I must take that something to the power of, sorry, that something must become the power of 10. Okay, so there are some examples in the notes that you can just go over. Antilog of, like this one in the book. Let's see, antilog of negative 4.8779. Okay, so remember antilog just means the answer will be 10 to the power of that something. 79. Okay, and this one you can work it out on your calculator. There it's 0.0000132. Okay, all right. So that is how you would do such a question. And that is what antilog means. So it's not something difficult. Now I want us to do some of the exercises in the book. I think we'll start with one each. Okay, mouse. Okay, I think I have it now. Now the first one here is we have 7.5 times 5 the fifth root of 39 over 1.8 times 1.8 to the power of 3. Okay, now we are told to use common logs in order to work this out. Now when you're given a question like this and it says to work it out using common logs, first thing you must do is you must equate this to something. Okay, so you'll say this is equal to A, it is equal to X, or something like that. So here I will let it equal to X. The letter you pick doesn't matter. Okay, then after you've equated it to X, now because you have a product in the numerator, product in the denominator, you can apply logs and then separate the terms. So I will apply log on both sides, and it has to be log to the base of 10. The reason it has to be log to the base of 10 is because it says use common logs, and common log means the base is 10. So this is log of 7.5 times the fifth root of 39 over 1.8 to the power of 3 times 2, and this is equal to log x over there. Okay, then you split this up using your laws of logarithms. I will work on the left hand side just because of the space that I have over here. You split your numerator and your denominator. Now with a fraction, the law says, let me see if I have the law number here. Law number 2, it says that if you have a fraction, when you split it up, the division becomes minus. So this is now log 7.3 times the fifth root of 39 minus log of 1.8 to the power of 3 times 2. So I had a fraction, and then when I split it, it becomes a minus. Then over here, I have a product. I can split the product. When I split the product, this becomes a plus. So this is, okay, this is all equal to log x, but I'm just working on the left-hand side. Okay. Okay, I can't fit that in, but it's fine. So I'll work on the left-hand side for now. And then to continue, this is log 7.3 times log the fifth root of 39. Okay, so sorry, not times, plus. So this is plus. I have a product. When I split it, it becomes a plus. And then this minus, now what I do is when I split this one over here, I have to put it in brackets to show that I am subtracting the entire thing. So I don't, if the bracket is missing, then that shows that I'm only subtracting the first part, which is not correct. So this is log of 1.8 cubed plus log of 2. Okay, so this minus shows that I'm subtracting this one as well as that one. So if the brackets are missing, then only this is negative, and then this one is positive, which is not correct. Okay, so still on the left hand side, I will just write this is log 7.3 plus now this, the fifth root of 39, that is just 39 to the power of 1 over 5. And when I have 39 to the power of 1 over 5, I can bring this down as 1 over 5 log of 39, and then minus 3 log 1.8 minus log 2. So this minus over here, I now multiply it over there as well as over there. Okay, that's why the log 1.8, the 3 log 1.8 is negative, and the log 2 is also negative. And then from here, you just work each of these out on your calculator like that. Now, because we're going to be rounding this off to 3 decimal places, what you should write down should be to 4 decimal places, and then your final answer is what you will round off to 3 decimal places. So I have my calculator here. I have log of 7.3. I get 0.8633. I hope that's what you got as well. And then the next one, 1/5 of log 39. This is 0.3182. And then the next one, negative 3 log 1.8. This is 0.7658. And then negative log 2. So log 2, this is 0.3010. So because it's 0, I do not need to write it. Okay, so again, I'm going to leave my answer to 3 decimal places. Usually that's what we ask you to do. So I round these off to 4 decimal places. Okay, and then I combine them. 0.8633 plus 0.3182 minus 0.7658 minus 0.301. Okay, I've done this correctly. I now get this 0.1147. And remember, this on the left hand side was equal to log x, which was on the right hand side. Okay, now we take anti-logs on both sides. So I'll just rewrite it so that I have log x on the left. This is equal to 0.1147. And then when I take anti-logs on both sides, the log will now cancel because log and anti-log are opposite operations. So I have x is equal to anti-log of 0.1147. Excuse me. Now remember what anti-log means. If you take anti-log of anything, that just means that you say 10 to that power. Okay, so this is just 10 to the power of 0.1147. Then this one you do on your calculator, 10 to the power of 0.1147, and then I get 1.302. So I'm going to leave it like that to 3 decimal places. Okay, so that's one way that we use anti-log. Is that fine? You can type in the chat, yes, it's fine, thumbs up, proceed, something like that. So I know you're all okay, you're still here.
Yeah, miss.
Okay. All right, so let's look at some more of the questions. Um, Now we are applying our laws of logarithms. Now I always say with your laws of logarithms, you just need to go one by one. Can I use this law? Yes. Can I not use this one? Move on to the next one. Eventually you will find one that you can use. So it's just a matter of saying, okay, can I use this one? Yes. Can I not? Okay. All right. So we're on exercise 3.71. Okay, we start with question one. Question one, I think some of these will be repeating, but it's okay. In each of the following, what is the value of x? So I'll pick B. We have 4 is equal to log base x of 16. Now we have to solve this one. Excuse me. Okay, so this one, what you can do is rewrite it in exponential form. Okay, so remember it is base exponent, which is 4, that one there. The subject of a log function, of a log equation, is always the exponent, and this is equal to your argument over there. Now we've done equations like this, they're very easy to solve. This x to the power of 4, you rewrite 16 as 2 to the power of 4. Okay, now our exponents are the same. There's nothing here for that side multiplying or dividing. Then it means that the bases are equal. So we have x is equal to 2. Okay, so that's that one. Then question 2. Rewriting this in exponential form. We've done, this was pretty much what the homework was about, but let's look at B just to emphasize. I have log B is equal to Q. Remember, it is base exponent is equal to argument. So it's base exponent is equal to the argument, and that's how we would do that one. Okay, question 3. We have to find the value of x. Let's start with A. 3a. I have log 3 of 81 is equal to x. Now with this one here, I have to apply some of the laws that I know. Now 3 and 81 are related because I can rewrite 81 as 3. Christoph, another example of what? You need to be specific. I think I saw that a little bit late. Okay, 81 and 3 are related in that 81 I can rewrite it as 3 to the power of 4. So here I will write this log 3, and then instead of writing 81, I have 3 to the power of 4 is equal to x. Now there's a law that says if you have an exponent, go ahead and bring it down over there, it'll multiply. So this is 4 log 3 is equal to x. Okay, now here there's another law that says if you have log of 3 to the base of 3, that means anything, you take log of anything to that same base, the answer is equal to 1. Okay, so here on the left hand side I have 4 times 1 is equal to x. That means x is just equal to 4. Okay, then C, I'll be doing every other one. C, I have log x of 16. This is equal to 0.5. Okay, usually when the base is unknown, what you should do is rewrite it in exponential form. So I will have base exponent is equal to my argument. So x to the power of 0.5, this is equal to 16. That's what I have over here. Okay, now remember 0.5 is the same as half, so this is x to the power of half is equal to 16. And when you raise anything to the power of half, that is the same as square root. So what I have here is square root of x is equal to 16, and this means that I can square both sides, Then I have x by itself, because now square root and square cancel, just like log and anti-log cancel each other. See, I didn't divide by square root. Cannot do that. The same way you cannot divide log. Okay, and then 16 squared, this is 256. Okay, and that is your answer. Then E, log 4x, this is equal to 5.5. 5.5 is just 11 over 2, so I'll rewrite it. This is 11 over 2. Okay, so with this one here, let me see. Okay, scroll down. Okay, with this one here, what I do is I will also rewrite it in exponential form. I have 4 to the power of 11 over 2. This is equal to x. So it is base exponent is equal to my argument. So 4 to the power of 11 over 4. This is the same as 4 to the power of half to the power of 11, because if I raise 4 to the power of half and then to the power of 11, I will have to multiply 11 and half, and that's how I get 11 over 2. Okay, and then this is equal to x. Now the reason I did that is because 4 to the power of half, this is just square root of 4, and then I raise it to the power of 11, which is equal to x. The square root of 4 is 2, so I have 2 to the power of 11 is equal to x, and that means x is equal to what? 2 to the power of 11. This is 2048. Okay, so that's the answer for that one. Then G, log 9, log of base 9, 27. This is equal to x. Okay, now here when the exponent is unknown, we apply some of the laws that we know. So I see 27 and 9, they are related. Not that I can write 27 as 9 to the power of something, I cannot. But I see that I can write 9 as 3 to the power of 2 and 27 as 3 to the power of 3. So here I'm going to use the method of changing the base of the logarithm. Now when you want to change the base of the logarithm, the procedure is very simple to do. What you do is you have a very big fraction. Okay, you have a fraction like that. Then you decide whatever base you want to, as long as it fits into the rules that we have, that your base must be positive and it must not be equal to 1. So I've decided I want to make my base 3, because 9 is 3 to the power of 2 and 27 is 3 to the power of 3. Then what you do is you put that new base there. So it's log base 3 in the numerator, log base 3 in the denominator. Okay, so I've decided I'm changing the base from 9 and I want the new base of the, or I want a logarithm that has a base of 3. Then the argument goes to the numerator. So this is 27, and then the base goes to the denominator, just like that. Okay, so that's how you change the base of the logarithm. And on the right hand side, I haven't changed anything, so it stays there as x. Okay, so one big fraction, whatever base I want, I put it in the numerator. In the denominator, the argument goes to the numerator, then the base goes to the denominator. Then I simplify my numerator and denominator as far as possible. So I'll write this as log base 3, and then we say 27. This is 3 to the power of 3. And then in the denominator, 9 is 3 to the power of 2, and then this is just equal to x. Okay, then the law that says if you have an exponent of your argument, your exponent should go down and multiply. So this is 3 times log 3 base 3 over 2 times log base 3 of 3, and this is just equal to x still. Okay, then log 3 base 3, I said earlier, this is equal to 1, and this one over here is also equal to 1. So in the numerator, I have 3 times 1. In the denominator, I have 2 times 1. This is equal to x. So that just means x is equal to 3 over 2. Okay. Let me also take a look at h. H, I have minus log base 16 x. This is equal to 0.75. Okay, now usually with these questions, what we did with the previous examples is we rewrote it in exponential form. Now, you should never rewrite in exponential form if you have a coefficient over there. Now, my coefficient is not written. It is -1. Okay, so this is the same as -1 log 16x is equal to 0.75. So there must not be any coefficient. So a coefficient must be 1 before you rewrite it. So what I will do is I will divide by -1 on both sides. So when I divide by -1 on both sides, now I have my coefficient of the log as 1, which is what I want. And then on this side, I have negative. I'll write it as 3 over 4 because 0.75 is equal to 3 over 4. Okay, then now I can rewrite it in exponential form because the coefficient is 1. If the coefficient is anything else, you must first divide by it or bring the coefficient back over there. Then you can rewrite it in exponential form. Okay, then when I rewrite this, I have my base exponent is equal to my argument. Okay, then here I have a negative exponent. Negative exponents, we said we can rewrite them as a positive exponent. Say 1 over 16 to the power of 3 over 4. I hope you remember this from your laws of exponents. Now this 3 over 4, I can write it as 1 over 4 times 3. So this is 1 over 16 to the power of 1 over 4 to the power of 3. Because when I raise 16 to the power of 1 over 4 and then to the power of 3, the same as multiplying the 2, and that's how I'll get 3 over 4. Now 16 to the power of 1 over 4, we did one example where we say 2 to the power of 4 is 16. So 16 to the power of 1 over 4, or the fourth root of 16 is equal to 2. So here I have 1 over 2 to the power of 3, because the fourth root of 16 is equal to 2. And then this is just equal to 1 over 8, because 2 to the power of 3 is equal to 8. Now question 4 is the same as the homework that I did, so I will not, or the home, yeah, that I went over, so I will not do that one. So you can just look at that Now, question 5, we have to evaluate. Usually when it says evaluate this, we mean without a calculator. So I must see all the working that you have done. This is question 5. The first one, let's start with A, log 2 and then 32. Okay, now to evaluate this one, we use the method we did. 32, I can write it as 2 to the power of 5. So this is just log 2 and then 2 to the power of 5. And then I have an exponent, or my argument has an exponent. I must bring the exponent down. So this is the same as 5 log base 2 of 2. And then we said when you take log and your base and your argument are the same, this is just equal to 1. So I have 5 times 1. This is just equal to 5. Then letter B and C, I'll do it in the same way. 36, I write it as 6 squared. C, 5, I think is that 5 to the power of 4. Okay, yeah, I'll write that 625 as 5 to the power of 4. Now let's look at D. I have log 2 of half. Now half I can rewrite as 2 to the power of minus 1 because this is the same as log 2, and here I have an invisible 1. Now in the same way that I did a previous one, I don't know where I put it. Okay, it's this one here with the 16. The exponent was negative over here, and when I brought it to the denominator it became positive. So the opposite is also true. I can't scroll down now. Okay, the opposite is true. If I have a positive exponent in the denominator, I can bring it to the numerator and then the sign changes. So here I will have 2 to the power of minus 1. I hope you remember that from your laws of exponents. Okay, then this one, I do the same thing. My argument has an exponent, so this exponent can come down. Then I have minus 1 multiplying by log 2 base 2. Okay, right, and then I said log 2 base 2 is equal to 1. So I have minus 1 times 1, and that is why the answer is just equal to minus 1. Okay, then one more, oh not one more, let's look at G. Log A. Now this one is given to you as a law, but we also want to see that you are able to show that, or where does this law come from? That's what the question is basically asking. Now to do this, what you can say is you let it equal to x, then you rewrite it in exponential form. So this is A, my argument, exponent, this is equal to, base exponent is equal to my argument. Then here, there is no exponent given. That means the exponent is an invisible 1. Okay, now my bases are the same, A, and that means my exponents are equal. So I have x is equal to 1, but x is here. So that is why I have log A of A is equal to 1. So in our list of laws, it's just given there, but this is how you would prove that it is equal. Then I think do the last one, J, log of base 27 of 3. Okay, now here what I am going to do is I'm going to change the base of the logarithm. Now remember, when we're changing the base, I make one big fraction. Now the base that I choose, you can choose any base that you want, but you need to choose a base that will help you. Now I see that 27 and 3, I can rewrite both of them as 3 to the power of something. And to do that, I change the base to 3, log base 3, and then log base 3. So the base was 27, the base now becomes 3, so I've changed the base. Then my argument goes to the numerator, and then the base goes to the denominator. So that's just the procedure we use. Argument, numerator, base, denominator. Okay, then log 3, base 3 is equal to 1. We established that one. And then log of 27 to the base of 3, I can evaluate that by rewriting 27 as 3 to the power of 3. Sorry, it's 3. Okay, then this 3, when my argument has an exponent, I will bring it down over there. So this is 1 over 3 log 3, 3, like that. And again, this part is equal to 1. So I have 1 over 3 times 1. This is just equal to 1 over 3. Okay, so I think we can stop here. Tomorrow our class is, what time is the class? Okay, it's at the normal time. I think it's supposed to be a double class, so is tomorrow the day when we don't have a class? Somebody remind me. Hello? Is anybody there?
Yes, miss.
Okay, what time is our class tomorrow?
Tomorrow is Wednesday.
Yes, we don't have a class on Wednesday. Is it the one at 2 o'clock?
We do. Yes, I
Okay,
think yeah.
okay. So the class will be this at the same
It's
at
1:50.
1:30. Okay, we can have the class at that time. It's fine. So you will just follow the same link and join the class at that time. So 1:30 tomorrow. Tomorrow is Wednesday. Yes, 1:30. Okay, that's fine. Right. So I've been recording this. I will save it. I'll put it on e-learning and also here on Teams. So those who are not able to make it can just watch it from there. Do you have any questions before we leave? Are we all good?
It's fine, miss.
Okay.
Yes, miss.
Okay, then I'll see you guys tomorrow. Or I'll hear you guys because I didn't see any of you. I'll hear you guys tomorrow.
Okay.
All right, bye.
Okay, miss.
Bye.
Okay, let's see, check out. Hi. What's going on?